Now we look at 1.2. Let me just get a pen. 1.2.2. 1.22. 1.2.2. There you are given 5 over x plus 3 minus 3 over 2 minus x. So we want this second term to start with x. So it's x plus 3. So we will take out the negative as a common factor. That negative will find that negative. Negative times negative is positive. Then we have 3 over x minus 2. We add them. If we add those terms, what is the lowest common multiple? Looking at our lowest common multiple here, it is x plus 3, x minus 2. Now, x plus 3 into x plus 3, x minus 2. What will be left will be x minus 2. That x minus 2 will have to multiply with 5. We have 5 into x minus 2. You write your plus. X minus 2 into x minus 2, it will cancel out x minus 2. What will be left is x plus 3. That x plus 3 should multiply with the numerator, which is 3. 3 times x plus 3. Down there we have x plus 3, x minus 2. Now remove the bracket. 5 times x, it's 5x. 5 times minus 2, it's minus 10. 3 times x, it's 3x. 3 times 3, they're giving us 9. Then we look at our next term. Or down here we have x plus 3, x minus 2. So 5x together with 3x will give me 8x. Minus 10 plus 9 will give us minus 1. The final answer we can clearly see it's 8x minus 1 over x plus 3x minus 2. That will be the answer for 1.2.2. Then we look at the next question. If you look at our next question there, then now our next question, let me just look for the next question. Next question is 1.2.3. Let me go up so that you can also see it. 1.2.3, 25 to the exponent minus 1 times 15 to the exponent minus 1 all over 3 to the exponent minus 1 times 5 to the exponent negative 4. Let us look at that one. Let us just look at it. Okay. I'm just going to look at the next question. There you are given 1.2.3, 25 to the exponent minus 1 times 15 to the exponent negative 1 all over 3 to the exponent negative 1 times 5 to the exponent negative 4. Now we must write 25 in terms of a prime base, it's 5 squared. There is still negative 1 outside there, times 15 in terms of prime basis, it's 5 times 3. There is negative 1 there. Down here we have 3 to the exponent negative 1 times 5 to the exponent negative 4. Step by step. Two times minus 1. So we have 5 to the exponent minus 2 times this minus 1 times 3. And so that exponent minus 1, we will have 5 to the exponent minus 1 times 3 to the exponent minus 1 all over 3 to the exponent minus 1 times 5 to the exponent minus 4. So this one will give us 1. We can cancel out. And then what will we be left with? Moving on. The bases are the same and we are multiplying. When we multiply powers that have the same base, you add the exponents. So it will be minus 2 plus minus 1. And then this one, you will take it up to those, this 5 and this 5. The bases are the same. That's why we have minus 2 plus minus 1. So this minus 4, if you subtract it up there, it will be plus 4. Then you are left with, moving on to the next step, it's 5 minus 2 and minus 1 is minus 3 plus 4, we end up with 1. So 5 to the exponent 1, which is 5. So that will be the final answer for 1.2.3. That's what you will get for 1.2.3. 5 will be the final answer. Then we can look at the next question. Then now they are asking you, let me look at it. Next question. Here they are saying, determine the value of 3p plus q squared, 1.3. They want you to find the value of 3p plus q all squared. This is a binomial, squaring a binomial. How do we square a binomial? Squaring, you square 3p, it gives you 9p squared. Multiply these two times. 3p times q is 3pq times that 2 up there. It becomes 6pq. Then you square q. If you square q, what do you get? You get q squared. But remember, you are told that 9p squared as q squared equals to 12. You are given. And you are also given that pq equals to, let me just check. PQ, we are told that PQ equals to something also. Let's see. PQ equals to, we are told that PQ equals to minus 3. So let's go back. PQ equals to minus 3. PQ is minus 3. So if you replace it, 9p squared plus q squared is 12. Plus 6. PQ is minus 3. 6 times minus 3. So this is 12. 6 times minus 3, it's minus 18. 12 minus 18 is minus 6. That will be your final answer for this one here for question 1.3. Now let's see. Let us look at